We're going to talk about quadratic functions today, look at some word problems. These word problems will mainly be asking you for maximum and minimum values. Some will be familiar from previous chapters. Those that are asking you for maximum and minimum values are really just asking you to find the vertex. So when your equation is in standard form, remember our vertex is hk, and h is found by taking negative b over 2a. K is found by finding f of h. It's very important to pay attention to the labels. Does H answer the question or does K answer the question? That is, if you find negative b over 2a, put a label on it, and that will help you figure out if that is the answer to the question you've been asked. So here's our first example. Toy rockets launched straight up from the top of a building that's 50 feet tall with an initial velocity of 200 feet per second. Now, you may recall when we measure in seconds, our A value is negative 16, our initial velocity is our B value, and our initial height is our C value. So that's where we came up with f of t equals negative 16t squared plus 200t plus 50. We're to determine the height at which the rocket reaches its maximum height and maximum height in feet. So maximum tells us we're looking for our vertex. I need to pay attention. This t value is time, so that's my h value is a time. And my f of t, well, that's a height. So I will find the h value to answer the first question and the k value to answer the second question. So negative b over 2a gives us 6.25. So 6.25 seconds is how long it takes to get to the maximum. And f of 6.25 is equal to 675, and since that's a height, it's 675 feet. And we've answered the question. Now, some of these problems will ask you to do things that you've done in previous chapters. So part B here is an example of that. For what time interval will the rocket be more than 300 feet above the ground level? Well, 300 is a height, so it's going to replace f of t, and then we've got this quadratic equation to solve. I prefer having an a value that's positive, so I'm going to subtract all three of these values to the left-hand side. And now I have 16t squared minus 200t plus 250 equals 0. I'm not going to mess with trying to factor that. I'm just going to go straight to the quadratic equation, the quadratic formula. So t is equal to negative b plus or minus the square root of 40,000 b squared minus 4 times a times c, all of that over 32. That gives me two answers. That is 1.4 seconds after it's been shot off the ground, it reaches the 300-foot level. It continues up to its maximum. On its way back down, then, it crosses the 300-foot level again. So in between 1.4 seconds and 11.1 seconds, this object is more than 300 feet above the ground. Question C is another one that should look familiar. After how many seconds will it return to the ground? Well, if it's on the ground, its height is 0. So 0 is what we replace f of t with. And again, I'm not going to mess with trying to factor that. I'm going to use negative b plus or minus the square root of b squared minus 4ac all over 2a. And I get two answers again. However, one of the answers is negative. That makes it extraneous. So I really do only have one answer. It takes 12.75 seconds to return to the ground.